Hello student, welcome to my YouTube channel. As I have told you in the last class, today I will teach you the vector operation. After knowing what are the vectors, now it is the what suppose it is the term for what to understand what is vector operations. So we'll see first what are vectors operations. Now, as you know, if we are playing with what scalar quantity like what mass, 5 kg of mass plus 5 kg more mass, this makes what 10 kg of what mass. Yes, this can be done by using simple algebra. But now, if you are saying 5 meter east plus 10 meter west or north equal to what? Then with the known mathematical operations, we cannot handle this. It means new approach or process is required. What will be that process? We are going to study how we will what add two vectors, how we will what subtract two vector, how we can what suppose we define the product of what two vector, and how vector division will be defined or what not defined, we have to see in this particular chapter. But in this particular class, I will take I'll take what some addition and what subtraction, and that I am going to what finish in this particular what lecture. So see here we can write what this as, suppose I am starting this operation vector operation with a new vector called as what equivalent vector, equivalent vector. See what are equivalent vectors, we have to see. Now just try to understand. If a person is moving 2 meter, or suppose it is what 5 meter towards east, and it is starting from what A and coming at what point B. A person moving first due east 5 meter, and then it turns and what again it is what moving 5 meter and reaching at what point C. Now if somebody is saying what this AC, this is what AC. So this plus what this, it means here we can what interpret, we will read it here vector AB together with BC is equivalent to vector AC. See, vector AB together with vector BC is equivalent to vector AC. It means what purpose will be solved by AB along with what BC? Yes, the same purpose alone will be solved by what? Vector AC. It means AC is equivalent to vector AB and BC vector. Now, the same can be what interpreted as see AB, BC and AC. Here we can say, here we can say vector, or we can say vector AC is resultant of vectors AB and A, AB and vector BC. Here we can say AC is resultant of vector AB and vector BC. Or we can say when AB composition of what vector AB and BC is nothing but what? AC. Now, if AC is what? Its resultant vector, then also we can say AB and BC are component vectors of vector AC. See here. Here, if you are defining the what suppose ki vector or equivalent vector in this way, this is giving you the future scope of what? Vector operation. It means ki 2 or 3 or 4 vectors can be added together and form a what? Resultant or what? Composite vector. And if 2, 3, 4 vectors can be added to form a what? Single vector, then a single vector also can be resolved into what? Different component vector. So it means what? Here in this particular what subtopic, we are going to explain how we can what? Superpose or what? Take the what? Resultant of what? 2 or 3 vectors, and how the vector can be what? Resolved, or a single vector can be resolved, because ki AC is superposition of what? Vector AB and what? BC, or we can say resultant of what? Vector AB and BC, or we can say ki AC is equivalent to vector A and vector AB and what? Vector BC. Now, similarly, if a vector AC is there, yes, we can say AB and BC are what? Its component. So, before going into the what? Detailed study of the what? Process of what? Making what? Resultant vector from the what? Different component vector, first we will what? Learn how to represent a vector in Cartesian coordinate system. Then very easily we can what? Compose, or we can what? Take the what? Equivalent or resultant vector, and we can also resolve the vector. So first we will see next small topic. First I want to discuss is Cartesian representation of a vector. Cartesian representation of a what? Vector. Cartesian coordinate system. Here you see it is a set of three axes. Here x, y and z axis are mutually perpendicular, or we are also called this as what? All the axes, all the three axes are orthogonal. Yes. Here, while suppose yes, I have to see all those aspects of what vector which will be helpful to understand the what physics. So that's why I am not going into the what mathematical, suppose mathematical application or mathematical importance of what this vector. So I am not going into that depth. What is what aspects of vector is required to understand the physics? Only those aspects of vector we are going to discover here before you. Now see, this is the what? Cartesian axis. Here x axis, y axis, z axis are what? Mutually perpendicular. Now suppose here we are taking a point. If we are taking a what point? First I am taking what? A vector which have what? Two dimension, which has two component only, vector in a what? Plane. But see, first Cartesian coordinate system, this is what here, and here see, unit vector along this direction is what? Denoted by what? I cap. Unit vector along what? This direction is denoted by what? J cap. Unit vector along what? Z direction is denoted by what? K cap. I, J, K again are what? Mutually perpendicular. Sometimes what? Suppose the in modern notation it is also denoted by what? X cap. This is also denoted by what? Y cap, and this is also denoted by what? Z cap or represented. So this is what has what? Symbolical importance. Yes, I, J, K are what? Unit vector along the respective axis. Yes, x, y, z, I, j, k, or x cap, y cap, and what? Z cap you have seen. Now, if you want to take a what? Suppose point P in xy plane, and if its coordinate is what? X comma y, and if you are making the line or joining the what? These two, and if you are representing this by a vector r, then here we are what? Defining, here we are defining OP vector that is represented by r is called as what? Position vector of point P with respect to origin O. With respect to what? Origin O. This is position vector of point P with respect to what? Origin. Now see, if you will draw the what? Projection of this, projection means what? If you are putting light from this, then a shadow cast on what? This x-axis will define its x component, and this, if you are what? Focusing light from this side, then the shadow or projection of this OP on what? Y-axis is representing what? Y component. So here we can write, just you see, here we can write here this x and y are x and y components of a vector r, and this can be represented as vector r is equal to vector x I cap plus y j cap is what? Vector. So it means this is how we can represent a what? Planar vector or a vector in what? 2D in this way, where x, suppose if we are defining a vector a is equal to ax I cap plus a y j cap, or this also can be written as vector a is equal to ax x cap plus what? Ay y cap. So it means ax and ay are x component and y component of vector a. Simple. So this is how you have seen how we can what? Represent a vector in xy or what? Axis or in xy plane, and this is what called as a what? Planar vector. Also it means what? It is having what? Two components. Now if suppose here vector is what? Suppose it is written in this way, then how we can what? Define its what? Magnitude. Just you see how we can define the magnitude of what? This vector a. So magnitude of what? Vector a can be defined as ax square plus ay square root. If ax is what? It's what? X component, and ay is its what? Y component, then squares. Yes, you can apply. This is what? Suppose if here we are writing what? Ax, this will be what? Ay. Yes, you can apply the what? Suppose Pythagoras also, or you can what? Write ax square plus what? Ay square. Yes, if you are representing r vector, magnitude will be equal to what? X square plus what? Y square root. Yes, so it means what? Magnitude of vector a can be represented by what? This, or measured by what? This, or representation is also you have seen. Now if suppose, yes, vector is what? Vector is having what? Direction as well as what? Magnitude. So here you have seen the magnitude, but if somebody will ask you what will be its what? Direction? Yes, suppose if it making angle theta with the direction of what? X axis. If this is making angle theta with the direction of what? X axis, we can write what? Tan of angle theta is equal to y by x. If you will go what? With this representation, yes, we can write what? Tan of angle theta is equal to ay divided by ax. So therefore theta can be written as tan inverse y by x. We can write this as a what? Theta. So this is how we can represent suppose a vector in two dimension whose component will be what? 2. So here x component and what? Y component. Now we will see, and here you have seen how you will represent a vector into what? 2 dimension or in Cartesian coordinate system, and how you will what? Calculate its what? Magnitude, and how you will what? Determine its what? Direction. Now we are going to represent a 3-dimensional vector in coordinate system or Cartesian set of what? Axis. Later on also we will see how we can represent a vector into spherical coordinate system as well as in cylindrical coordinate system. So now you see the 3-dimensional vector. Just see how I am what sketching the what figure. This is the what origin, its coordinate is what 0, 0, 0. Suppose I am taking what this as x-axis, this as, चलो इसको x, just I am taking what this as what x-axis and take this as what y-axis and this as what z-axis. Yes, this is what x-axis, this is what y-axis. Suppose here we are taking a vector here we have taken a vector that is, see here, this vector is, suppose here we are taking this as a what vector r, and if we are considering the coordinate of this is what x comma y comma what z, then see, if you will draw perpendicular here, then its projection on what xy plane will be what this. So now see, if this is what the projection of what O P vector or R vector on this xy plane, then see, this will be its what x component and this will be its what y component, and see here it will be its what, here if you will take what this here, then see here will be its z component, so here will be its what z component, here see here will be its what z component. So now see, this is what x component, this is what y component, and this is what its z component. So this vector r can be represented as x I cap plus y j cap plus z k cap. Just you see, this is one diagonal vector. This is representing the diagonal of what this cube. See the figure in a what proper way. So this is what x component of what this vector, this is what y component of this OP vector, and this is what, so that this vector r can be expressed in what its what x y z component in this way. Now r vector, yes, here see. Now we want to calculate its what magnitude. See from the geometry, if you will take the projection of what this here, this suppose here we are taking a what OQ vector. See, this is what z, this is what suppose here, this is z, and this is what suppose y, and this is what also will be equal to what x component, this also will be x, this also will be what y. So therefore we can write this x, this vector as x square plus y square root, because see x square plus y, this is what y square plus x square will be equal to what this. So the measurement of what OQ, magnitude of what OQ will be equal to what this x square plus what? Y square. And remember this is 90 degree. This is 90 degree. Therefore, if this is what z vector, QP is what z vector, then OP vector ka its what magnitude will be equal to square, will be equal to x square plus y square root whole square plus z square. Yes, everywhere we are what applying the what Pythagoras. Now suppose ki here OP vector, that magnitude is equal to x square plus y square plus what z square and its square root. And OP here we can represent, we have represented r vector magnitude, and this will be equal to x square plus y square plus z square root. So now and onward we will write directly. If the vector r is given in terms of what x, y, z component, then its magnitude can be written by what? This magnitude is equal to x square plus y square plus z square. Now if here you have what written this as what r square, r magnitude of what vector is equal to what x square plus y square plus what z square. Now see whether this vectorially it is what coming correctly or what not. Now see, this is what vector x y yj vector we can write. This is what, suppose ki here see कि this is what x vector, this is what x vector, this is what y vector, this is what z vector. Now see, this is what x vector, this is what y vector, and this is what z vector, and this c. So this vector A plus B plus C is equal to this vector. This is what r vector. Though this is what, this picture is what appearing in what plane, one plane, but here this vector in this plane, then suppose this is also what this plane, and here see, here this is the in this plane, and here this OP vector is representing the resultant of what? Vector A plus vector B plus vector C. That's why we have written here r vector as equal to xi cap plus yj cap plus what? Zk cap. So here if you will visualize this figure, then also you see here that this vector OP is making angle, some angle with what? Alpha with what? X-axis. This is what? Making some angle with what? Beta with y-axis. And suppose this is what? Making gamma angle with what? Axis. So cos of angle alpha is equal to x component divided by r complete vector. Similarly, cos of angle beta is equal to y component divided by magnitude of what? Vector. Similarly, cos of angle gamma is equal to z by magnitude of what? R vector. R vector. Now see, cos alpha, we can also write this as a what? L. We can also mathematically, it is of what? No use in what physics, just I am what for your information I am what writing here. This is known as what? Represented by m, and this is represented by what? N. So this is L, M, N are known as direction cosines of what? This. Now see, if you are what? Suppose here L, M, N are called as called as direction cosines of what? Vector OP with respective axis x, y, z respectively. Now, see, if here cos alpha is equal to what? X by r, magnitude r, and cos beta is equal to what? Y by vector r, magnitude, and cos gamma is equal to what? This. Now, I am what? Giving you square of what? This vector. So, see, if you are what writing, if we are what writing this, yes, see here, I am going to what? Delete this. So, before rubbing, just I am what reminding, if it's a vector 3, if you want to express a vector into 3 dimensions, yes, see, vector r can be written as what? X component I cap, y component j cap, and z component what? K cap, and its magnitude can be written as what? X square plus y square plus z square. It means what? Square root of what? Is sum of squares of what? Component vector. And direction of what? Means what? If the alpha, beta, gamma are making angle with x-axis, y-axis, and what? Z-axis respectively, then these are called as the what? Directions cosine of what? The vector. So if you see just I am giving you what? One mathematical operation of what? This, if cos square alpha into cos square beta, suppose here cos square alpha plus cos square beta plus cos square gamma, this is coming equal to, just you see, x square by r square plus y square by r square plus z square by r square. This is coming equal to r square equal to x square plus y square plus z square. And now if here see, as we know r square is equal to x square plus y square plus what? Z square. So here this will be equal to what? 1. So it means what? We can write here again. L square plus what? M square plus n square is also equal to what? 1, because L also representing cos alpha, M also representing what? Cos beta, and N also representing what? Cos gamma. So it means what? These are the what? Direction cosines. Yes, in very few places you are going to use this approach or operation of what? 3-dimensional what? Vectors in physics, as far as what? The basic intermediate course is concerned. Yes, I will go into the depth of what? This 3-dimensional vector also, but it will be given in the what? Next, suppose ki other lecture. So here you have seen how we can represent a vector or a vector in 2 dimension in Cartesian system and 3 dimension in Cartesian